You should all have gotten a notification now that recording has started. Thank you for joining out there. This is our third webinar in the series of 6 in total. I am, just as the last time, Robert Jensen. I work as the lead system engineer for VMware. And today, it's not only about me, thankfully. So I got some really nice help from my colleague, Viktor, who's also lead system engineer at VMware. So the agenda for today, actually switch this one. The agenda for today is all around delivering Kubernetes as a service to your users. And the topics we have is around multi-cloud deployment, talk a bit about policies, guardrails, talk about scale out, a bit about upgrades, backup. And then that's the part I will cover today. And then it starts to get interesting. But then we'll talk about the complete automated delivery with continuous delivery on top. So if you remember from the last time, we talked about continuous delivery. And this time we'll build on top of the Kubernetes clusters that you're actually delivering. So if there's any questions, etc., then just use the Q&A and post them. My colleague Vesco is here as well, and will also be looking after the Q&A. So just post it, and if it makes sense to interrupt the speaker, then he'll do that. If not, then we'll take it in the end. So the purpose of this webinar series is still to give you an introduction to cloud native concepts and technologies. And the idea is to really start with the basics. We really want to get everybody on board, but we also want to cater for the more advanced users. So we will be more advanced during the session or during the webinar series. So I hope that's interesting. Today, the topic is Tanzu Mission Control, and that is the solution that we'll be using to deliver these Kubernetes clusters. So I see a couple of you has raised hands. If it's not by mistake, then use the Q&A. Then that's the way to get in contact with us or ask something. So Tanzu Mission Control is all about how do we deliver Kubernetes to our users. So what is Tanzu Mission Control, also called TMC in short? So TMC is a control plane. It can be either delivered as a SaaS solution or as something you host yourself. So, and it delivers policy management, lifecycle management, backup, application, app store, catalog, and identity access to all your Kubernetes clusters. And it does that by either deploying them from scratch. That could be in public cloud or in your private environment, either on Amazon using EKS. That's Amazon's Kubernetes managed Kubernetes offering. We can use Azure AKS, so Azure's managed Kubernetes offering, or a vSphere endpoint. That vSphere endpoint can be both on VMC on AWS, it can be on all the other VMware solutions, but it can also be in your data center. And it can also be in the edge. So if you have an edge location that supports vSphere, then you can use that. But it doesn't stop there, because you might already have some pre-deployed clusters that you want to manage and attach policies to, and etc. And so we can attach existing clusters. That can also be EKS, AKS. It can be GKE clusters from Google. It can be your OpenShift clusters, Rancher, or actually any conformant Kubernetes cluster. And conformant means a cluster that is within specs for the standard of how you deliver Kubernetes. That's probably the best way to say that. So, but when we attach to an existing cluster, then we lose one thing. We're not able to do the lifecycle management. So the lifecycle management part requires us to have deployed the cluster to begin with. So if you attach something already existing, then we're only able to apply, and I say only because it's quite a lot of things we're able to do, but we are still able to apply policies, manage namespaces, deploy packages, do backup, and all of those things. But we're not able to upgrade them in an easy way. So you need to use whatever tool you normally do to do that. So my presentation today will only be PowerPoint. So I'll leave the demo for Viktor. So again, as I said, that is the interesting part. But I wanted to show some of the concepts and how easy it is. And I won't really show the result because it is really next finish. But the first one is scale out. And scale out is all, let's say you have a Kubernetes cluster, and let's say you want some more worker nodes and more resources for your applications. All you need to do is go into the UI, looks a bit like this, select the Kubernetes cluster. In this case, I have one called CD. It's short for continuous delivery. You edit it, you go to the node pools, that's the workers you have, and you say edit, and then you change the worker count. You can scale it up and you can scale it down. As long as there's resources underneath, that's all it needs. Save, and that's it. We take care of the rest. So it is really that easy to scale your cluster. So, and you can do that as much as you want. I'm pretty sure you can do it using the API as well. So if you have some kind of trigger that wants to scale your cluster when you have more load, then that's also possible. Upgrading a cluster, just as easy. So again, you select the cluster, and you can see the one in the middle here. It actually it's some old version. So yeah, that's how it is in this for these screenshots. But you can see there's a little question mark outside the middle one, and it says upgrade available. And all you need to do is click on it and say upgrade, and then it asks you what version do you want to upgrade to. One thing to bear in mind here is when we deploy a new cluster, then we're able to have 1 or 3 management nodes. If you only have 1, that is fine for test, etc. But if we upgrade a cluster that only has 1 management node, then you will probably have some downtime in your management of that cluster. If you have 3, then you can upgrade seamlessly. So that's something to bear in mind, and we'll put in a little warning around that. So. But one of the things that I think is most interesting, not seeing the continuous delivery part that Viktor will be talking about, because in my opinion, that is probably the most interesting one. But we want to manage the Kubernetes clusters that we give to our users. We want to make sure that there's the correct set of guardrails, permissions, that we don't just hand the keys to the kingdom to an end user and say, do whatever you want. We want some kind of control. And that's what the policy management is all about. So the way we do that is we divide our users, our personas, into 2 different parts. One being the platform operators, the other one being the application operators. It can be the same, but for this example, we'll divide them. And the platform operator can create something they call a cluster group. And the idea behind a cluster group is that you have 1 or more clusters in some kind of logical grouping. And we can apply some policies, some access control to that. As a user, I might not want to have access to an entire Kubernetes cluster, 1 or more, because there's a lot of things native to Kubernetes that I don't need access to. I just need access to my namespace that contains my applications. And that namespace can reside on multiple clusters. So what we do there is we create something called workspaces. And a workspace is namespaces. It's a group of namespaces across multiple clusters. And on those workspaces, we can attach policies. So I can have one called test and I can have one called production. And those 2 might reside on different clusters. It might both be in public cloud. They might be in a private cloud. And they might be labeled just both test and production. I have different policies depending on what type of application and the SLA I need. So an example of that, and this is a bit complex, this one is, if you look at I hope you can see my mouse here, but it's, you can have a rough access policy, who can actually access my entire environment, and that might be the administrators. But then I might have a subset of users that need to have access to a couple of clusters. And then I might need another subset of users that only need to have access to a certain namespace. So you can divide it any way you want. So it's quite granular in this case. And what can policies then be? So one that I really like is I want to access the limit to different image registries. So if you remember from the last time, image registries, that's where we keep our container images. So, and we can use Docker Hub, that's fine, but it also contains a lot of crapware. And there's a good chance that we don't have control of what's actually inside the containers. So we might want to restrict it to container registries that we have access to. And in this case, I can select a workspace or one or more and say, I don't want them to use Docker Hub. Docker Hub is not allowed. Only my local registry is allowed. But I might also set something that, for example, the latest tag. So if you remember, if you deploy a container, if you select the last part of it and you say latest, it will always download the latest, not best practice and everything. But I can actually disallow that. So in test, that might be fine, but in production, that might be a no-go. So I can define that depending on what kind of workspace I use. Another example could be like network traffic. So I might constrain different workspaces, different namespaces from having ingress traffic, so nobody can communicate from the outside, but in others it might be allowed. And there's also something about how pods can communicate with each other across namespaces, etc. So it's kind of like microsegmentation for containers. I can define the same set of boundaries within the namespaces and pods. And an example here could be that, let's say I have a front-end application and a backend database. The front-end is, of course, allowed to communicate with the outside world, but the backend, the database, is not. But I set up a set of policies that allow me to communicate from the front-end to the backend. So I can really fine-tune this. And everything here is done by labels. So it doesn't matter if I kill the container, deploy a new one, as long as it has the same label, or if I scale it out, it will the same label will still apply, and the rules will still apply. So that's fairly interesting. We can also define what we call quotas, and this is not vSphere quotas. It's not Kubernetes quota. It's from the deployment of the pods. How many resources is a pod allowed to actually use? And I can set that on different workspaces and say, yeah, you're not allowed to use more than 2 CPUs and X amount of memory, for example. And then it can still scale out, and each one will use that amount of CPUs and resources, but I can't set one that just consumes everything. So that's definitely a best practice to always define quotas, and here I can define what the limit of those quotas is. I can also set other security policies. Most of this is included, but one good example here that I like is not to allow privileged containers. And what is a privileged containers? So that's a container running where the user, the service inside of it is running as root. So you don't want that, because if somebody hacks your container, then they suddenly have access to a lot more. You always want to constrain that and make sure they're always running in user mode instead. So, and that's something we can set as well. And you can define all of these and also custom templates that you can apply. Easy, you define them once and then you can apply them to different workspaces, etc., and you reuse them. And everything here is usually what the tool that we use underneath the covers is called OPA, Open Policy Agent. It's a CNCF project, so it's fairly easy to get started with. It's one of the many that exist out there, but it's fairly used out there. So, and we can also see some details around how is it actually, what violations do I have. Then we have a bit of data protection. So what we do there is we are able to integrate with our backup product, open source tool called Velero. But when you use Tanzu Mission Control, you get a UI, a really nice UI where you can actually see how to set up backup things. You can point it to different target locations, and you can even restore to another cluster. So we can even use this to migrate from one cluster to another if you want to do that. And all it requires is an S3 compatible target. So that could be S3 on Amazon, it can be a blob storage, and it can be mini IO locally if you want that. So it is fairly easy to use. So and it's open source, so and being used by a lot of other vendors as well as the engine in their backup solution. With that, and 1 minute early, according to what I promised, I will hand it over to Viktor, and you can present yourself now. I just more or less skip that part, and I will shut up until the end.
Yeah, okay, thank you, Robert. So good morning, everyone. As Robert already told you, my name is Viktor van den Berg. I'm a colleague of Robert. We're in the same team. I'm a lead solution engineer as well, just focusing on the Tanzu solutions that we have at VMware. Today, we're already talking about Tanzu mission control, so that's interesting. Or that's an interesting topic, I think. I will tell a bit more in a minute about how we do, let's say, GitOps-like stuff with Tanzu mission control. We'll talk a bit about tools like Terraform, Customize, Helm, Flux. It's going to be interesting. Before we move on, maybe a quick look first at our, let's say, demo environment. And that's what we have here. So this is Tanzu Mission Control. So Robert Jensen already showed you some screen dumps, but this is actually a live environment. Tanzu Mission Control is available as a SaaS solution, but also as an installable solution. So for organizations that are not really allowed to use public cloud, we provide an installable solution of Tanzu Mission Control as well, called Tanzu Mission Control Self-Managed. So this is the screen. Nice launchpad when you open Tanzu Mission Control. A few concepts Robert already touched on, but let me show them to you in the live interface, because I will talk a bit more in my presentation. So first of all, and this is an important starting point, the concept of a cluster group. So a cluster group is like a folder. Maybe it's also a container, but not a container in the sense of a pod running on Kubernetes, but it contains a list of Kubernetes clusters. That's what it is. So we see different cluster groups here. This is a demo environment. So Robert and other colleagues are using this environment. And when you open a cluster group, you see the clusters that are running inside of the cluster group. So in this case, this is my cluster group, and this has a Azure cluster running. And this allows you to access the cluster. And of course, you can get a lot of information on the Kubernetes level about this cluster, which nodes are there, which namespaces, what workloads are running, etc., etc. You can also add extra functionality. You can, using Tanzu Mission Control, you can integrate the cluster with our other solutions. For example, if you need service mesh technology, we can do integration here by just simply clicking Add Integration and then connect to the service mesh solution. And the same counts for monitoring observability. Another important topic is workspaces, and workspaces is something that will hold the namespaces you created on your Kubernetes cluster from TMC. So that's also something that is interesting to know and to understand how this works. Two other things I want to show you. First of all, the policies already briefly mentioned. So we can create policies, and these policies determine how your Kubernetes cluster runs, what is allowed and what isn't allowed. And you configure this on the cluster group level. And that's interesting because then when you add clusters to a cluster group, the policy will automatically be applied to the cluster that is added to the cluster group. So here you can create a security policy, for example, or choose for any of the other policies. Another thing that might be of interest is access management. So we can set access policies on the cluster groups. We can link user accounts to that, and we can create a kind of a, let's say, single sign-on portal for your environment, for your Kubernetes cluster. So that means that if you go to a cluster group, you can choose to access this cluster through Tanzu Mission Control using access this cluster, and then it tells you how you can how to access this cluster using the authentication authorization built into Tanzu Mission Control. Okay, that's nice. And then the question, of course, pops up: do I have to set up this whole Tanzu Mission Control platform myself, or can I do this in an automated way? So let's talk a bit more about that. And let's switch to my presentation. That one is here. There we go. So first, what I want to show you is, of course, you can choose to configure your Tanzu mission control environment through the UI. We just export the UI, but we also have a Terraform provider available for Tanzu mission control. So the first question then to ask, of course, is what's Terraform? And most of you, I guess, will know this solution, but Terraform is a infrastructure as code tool that allows you to build, change, and version cloud and on-premises resources safely and efficient. So what we can do with Terraform is create a definition of your, in this case, Tanzu mission control environment, capture this in a couple of files, and then use Terraform to apply this to the Tanzu mission control Terraform provider that will translate all your configurations to the TMC API and configure your environment. The way this works is that you first have to define your infrastructure in configuration files. Then you can execute the Terraform plan command, and that will show you what the result will be after applying the Terraform environment. And if you agree with the new setup, with the new architecture, then you can apply the Terraform configuration. And that means that the configuration is applied to your Kubernetes cluster or clusters, or you can even create Kubernetes clusters. A lot of the Terraform provider selects or supports a long list of resources. You see them on this slide. So if we want to use Terraform in combination with Tanzu mission control, we need, of course, a client that is running the Terraform executable. Then we need to configure a token. We need to request a token from Tanzu mission control that allows the Terraform provider to gain access to the Tanzu mission control environment. Then we run a Terraform init command. This will actually download and install the Terraform provider for Tanzu mission control. And after that, we can use the provider to configure the list of resources you see on this slide. So what we can do is cluster lifecycle management. We can automatically create and deploy AKS clusters, EKS clusters, and TKG clusters. So on Azure, on Amazon, and on VMware. We can also attach clusters. So if clusters are already up and running and you want to attach those clusters to Tanzu mission control, we can do that as well with the Terraform provider. Cluster group creation is there. We can configure Git repositories and customize configurations. I will tell a bit more about that in a couple of slides. So let's leave that for now. What else can we do? We can create namespaces on your Kubernetes clusters. We can configure the policies. We can configure the Tanzu service mesh integration, and we can configure the workspaces object. So this is more or less on the infrastructure layer. So how does it work? We need to do some initial configuration. We need to define the provider.tf file. And this file tells Terraform that we're going to use the Tanzu mission control provider. And then we need to set the endpoint. And the endpoint is the API access point of your TMC environment and the API token that we request from TMC. That's also something we need to configure. After the Terraform init, we can do Terraform plan. And here you see some basic examples. This is, for example, the file to create a cluster group. This is a file that allows you to configure a Git repository. And this is the file that allows you to create a new Tanzu Kubernetes Grid cluster on vSphere. So we run Terraform plan. Then Terraform tells us what resources will be created. And if we agree with that, we can do Terraform apply. We can auto-approve that the configuration will be deployed automatically, or we have to approve it manually, and then all the resources are applied. are deployed. So then also there's the Terraform destroy command, and the Terraform destroy command will, of course, destroy your configuration, the resources you have deployed. So let's have a look at that and also do a quick demo. So here we are in Visual Studio Code, and I created a basic Terraform configuration with some nice stuff inside of it. So first of all, we have the provider.tf that is required to do the, to connect to Tanzu Mission Control. The endpoint and the API token are available in my variables file over here. In my Terraform TFRs file. There they are. And then we're going to create a cluster group. For example, we can create a, let me see, where's that? A policy, a security policy. We can create a Kubernetes cluster. That's a bit longer configuration. So here I'm defining how many control nodes do you need, how many worker nodes do you need, etc., etc. We're adding some Git repositories, and we're doing some customization. Okay, so let's execute this file. Let me see. There we are. So I'm in the Terraform directory, and there we see all the TF files. And now it's nothing more than Terraform plan to see what will be happening. So 7 resources will be added, nothing will be changed, and nothing will be destroyed. Now, let's just go for it. Terraform apply. And now you will see, I have to say yes, that we will create a new configuration inside of this environment. The cluster group is created. On top of this cluster group, some policies are created. There is a Git repository that's created or linked to the cluster group, all in an automated way. And what's also happening that my TKG cluster is deployed. So we'll not be waiting for this because this will take a couple of minutes. But if we go into the Tanzu Mission Control interface, we see there's a new cluster group called Victorious-TF for Terraform. If I open that, you can see that there is a new Kubernetes cluster called TKG01 that is now being created. That's good to know. Okay, so that will take some time. This will take a couple of minutes. On top of that, some additional configuration is applied, like we have some Git repositories that are linked to this cluster group. And again, I will tell a bit more about that in a minute. And customizations will follow. If we look on the vSphere level, so inside my vSphere environment that is connected to Tanzu Mission Control, what we see here is that this TKG Kubernetes cluster is now being created inside of vSphere. So the steps that are executed here is Terraform apply. Terraform is connecting to Tanzu Mission Control, is telling Tanzu Mission Control, create a cluster group and create a cluster inside of that cluster group. And then Tanzu Mission Control on its turn connects to my what is called supervisor cluster on a TKG level. And that's the management cluster for my Kubernetes environment that's running here, and tells the supervisor cluster, okay, I need a new Kubernetes cluster, and please follow these specifications as defined in my Terraform file. So that's what's happening now. Again, this will take a while, so let's leave it and let's look later in this presentation if the deployment is successful. Let's go back to the presentation. So let's say that we have this Kubernetes cluster available. It's up and running in our environment. And now we need to maybe configure this Kubernetes cluster on a Kubernetes level. And we also might want to deploy some applications to the cluster. The question then is, do we want to do this in a manual way, or do we want to do this in an automated way? And of course, today we're going to talk about how to do this in an automated way, doing continuous delivery with Tanzu Mission Control. So I think Robert explained the concept of GitOps in the previous webinar, or maybe in the first webinar. And GitOps is something that's, well, very close to continuous delivery, because what we're doing with GitOps is that we have a Git repository that is a version-controlled repository that contains configuration files that define how my Kubernetes cluster should be configured and which components should be installed on top of this Kubernetes cluster. And these components can be full applications, whatever you want to use, or can also be, let's say, common components that you need on a Kubernetes cluster. For example, something like Cert Manager for certification, requests and approval and connecting them to the apps. Or it can be about, for example, external DNS if you need DNS integration, or it can be about logging that you want to configure. All those kind of basic components you need on a Kubernetes cluster. And we can use GitOps for that to deploy all these components. So we're going to dive a little deeper into this. So how does it work? So if you look at basic GitOps, then we need some kind of Git repository, maybe using GitLab or GitHub or another solution. Then some magic is happening, and then our Kubernetes cluster is configured, or an application is deployed, or whatever you need to have there. And then the question is, of course, okay, the magic in the middle, what's the magic about? So we're going to look at different tools that are helping us to do this magic in this environment. So first of all, there is a tool called Customize, and Customize provides a declarative and layered approach for Kubernetes cluster configuration and deployment. Sounds like something that we need. It also allows you to do configuration of applications running on Kubernetes, and the nice thing about Customize is that it is natively built into your kubectl command line interface. So that's one tool we're going to use. Another tool is Helm. You maybe heard of that. So Helm is a package manager that automates the creation, packaging, and configuration and deployment of Kubernetes applications. So a lot of applications are packed in a Helm package. And the third tool we're going to use or to look at is Flux. And Flux is a tool for keeping Kubernetes clusters in sync with sources of configurations. And it also automates the updates to configurations of your app, whatever you're deploying. And what we're going to do is make a combination of Customize, Helm, and Flux. Flux is used to make sure that the configuration on Git is synced with your Kubernetes configuration. And then we use Customize and Helm to configure your cluster or deploy apps. So Customize and Helm, it's different technology. It's a bit overlapping, to be honest, but this is an example of a customized configuration. So a customized configuration is defined in a customize.yaml file. And this customize.yaml file refers to your normal service.yaml or deployment.yaml configuration. So that's a customized file. The nice thing is that Customize supports what is called overlays. So what does that mean? That means that you can create a basic definition for an application, the base, and then create a specific configuration for a typical scenario. So for a staging environment, you want to have a different configuration of your app than for a production environment. So what does this look like? If we look at a customized example, I have it here and I'll show it to you. So we go to Customize, and in this case, I'm talking about a web server. So this is a very simple customization.yaml file. And what you can see here is that this customization.yaml file is referring to a web server deployment configuration and a web server service configuration. And I can add some extra components now to the whole setup of my application. So I can add labels, I can add annotations, and I can also choose to create a config map. And a config map is a object in Kubernetes that can be used by your application and contains configuration data. So this basic customization.yaml file, if I apply this, then this application will be deployed. I can also choose to create an overlay. And in this example, I have a production overlay. And what's a production overlay? So I go to the customization.yaml file in the production folder. What you see here is that I make a referral to my base configuration. And then I tell for this production deployment, I'm doing some patches. I want to do some changes to the original configuration. And that's what you see here. So I see a patch of the deployment YAML and a patch of the service .yaml. For example, in a production environment, I need more replicas, or I need to deploy this application to my production namespace. So I can do specific configurations for this scenario. Same counts for my development environment, and then you see development, and when I looked at the patch here, I only have one replica because it's a development environment. So that's what Customize is doing. Other technology we're using, or I want to discuss with you, is Helm. And Helm is a pretty common option for packaging of Kubernetes applications. It allows you to, actually retrieve a app from a Helm repository or a Git repository that holds your Helm configuration. You do a simple command like Helm install, refer to the Helm chart, what it's called, and then you can configure the parameters for your Helm, for the Helm chart you're using, and it will be deployed to your Kubernetes environment. And that's what we call a release. So if we talk about Helm, we're talking about a Helm repository that holds a Helm chart. A Helm chart is a package for an application. Then you deploy the app, and the result is that you have a release. That's a running instance of your application on top of Kubernetes. Most of the time, you're configuring a values.yaml file, and that holds the configuration that's specific for your environment, the values.yaml file. Now, let's put these components now together. So, Helm, Customize, and Flux. And then use Tanzu Mission Control, because Tanzu Mission Control has Flux, Helm, and Customize inside of the solution. And this allows us to do GitOps. What we can do here is that somebody that's managing or operating Tanzu Mission Control can connect to a Git repository over here, that holds a customized configuration and or a Helm configuration, link to this configuration, install the continuous delivery components to your Kubernetes clusters, the Kubernetes clusters that are attached to Tanzu Mission Control. And this allows you to apply a customized configuration or to deploy a Helm chart to your cluster. And also when the configuration that's on Git, if that changes, Tanzu Mission Control will take care of any updates and will apply them to your Kubernetes environment. And this allows you to have keep your application in a consistent state following the configuration that is available on your Git repository. That's what this is doing. So that means that you can define your cluster settings, describe your cluster configuration or application configuration in a YAML file, add that to Tanzu Mission Control, and then deploy this configuration using Flux to your Kubernetes environment. That's what this is doing on a high level. So that means we can do full automated cluster operations using this continuous delivery GitOps concept. So we're already using Terraform for the infrastructure as code part. That's there. We're using FluxCD to push configurations on the Git repository to your cluster. And this together allows us to set up a multi-cloud, multi-cluster Kubernetes environment and deploy apps and or Kubernetes cluster configurations to your environment in a standardized way, controlled by Git and fully automated. And your Git repository in this case is holding your configuration. That's what's happening here. So again, we can go to the next slide. So if you are an operations team and you are enabling the continuous delivery configuration or enabling the continuous delivery capability on a cluster group, then it will be enabled on your clusters. Then you configure your Git repository that holds the configuration you want to apply to your clusters. And then you use Customize and also Helm to apply this configuration to your Kubernetes cluster. Any Kubernetes cluster. It doesn't really matter which one you need here. So the Git repository will hold your YAML objects and deploy your apps and configurations to your Kubernetes clusters. Okay. Are there any questions, Robert, before we switch to the demo?
No, I think you should just go on with the demo. So.
Yeah, okay, I'll do that. So let's go back to our environment. And let me see what the current configuration is. Give me 1 second, please. So we initially did the whole configuration of the we applied the Terraform configuration. And as you can see, we now have a victorious Terraform cluster group. This cluster group now holds my TKG cluster. It's here. It's up and running. If we look to the add-ons, we see that we have 2 Git repositories configured here. These 2. So there's a Tanzu demo essentials Git repository and a microservices demo that is also configured. These 2 Git repositories are pointing to my GitHub account. And you can check the configuration yourself if you're interested in this. So we have a Tanzu demo essentials environment that holds some stuff. And I also like this microservices demo. And this is actually a web shop. This is coming from Google. The nice thing about this web shop is there's a customize folder. So we can use customize here to deploy a full app. So this is about a full app deployment using customize. Yeah. What you see here is that we're pointing to this microservices repository and also to another repository. So let's first have a look at this microservices repository, because if I look at installed customizations, you see here that a microservices demo customization is applied to this cluster group, and in that way also applied to the clusters that are running inside of this cluster group. So what is this customization? Let's check it out. It's pointing to a folder called customize, and this is actually this folder we're looking at. And this folder holds my customization.yaml, and this is the configuration for this specific app. Okay, very good. So now let's have a look on the Kubernetes cluster. TKG1 has just been created. There we are. if we look here on add-ons, we also see that my customization is applied here. So it's running on this cluster. When I go to namespaces, I've created a namespace called shop. This has all been created in an automated way. I've done nothing. Yeah, I've pre-configured all the stuff, but this is all created in an automated way. And then if I look inside of shop, you see that my deployments are up and running. There we are. For the people who know vSphere 7, sometimes you run into a PSP configuration that doesn't allow you to deploy certain apps. So sometimes you have to disable that. I have done that through a policy. So there was also a policy configured. Here's the victorious.tf cluster group. And you see there's a new policy here. And this policy has disabled my pod security policy. So that allows me to deploy this specific app. It maybe not the best practice, but in this case, this is required. So this app is up and running. And when I go to my command line, give me 1 second, because I have to log on to this specific cluster. And there's this one. There we go. So now I need to paste my password there. So I'm now on the command line going to my cluster TKG1 that has just been deployed by Terraform. This cluster holds a shop namespace, and if we look in the shop namespace, we see the app, and it's now running up and running for about 7 minutes. We can also request for the services that are up and running, and let's paste this IP address paste it here inside of my browser, and now we have a full shop available. So using TMC, Terraform, and Customize, I've created a new cluster group. I've deployed a TKG cluster on vSphere, could also be AKS cluster or EKS. I have configured some policies, and I have deployed this specific online boutique application. I can even update the configuration of this application. I go to the customize file, and I want to, for example, update the branding of this file. So let's go here, remove this hash, commit, I'm going to commit it directly on the master branch. And now it will take about, I think, a minute that my application will be updated and will show the new branding. That will take a while. We can check later if that has happened. So one other thing I wanted to show you, and then I'm going to wrap up because we're almost at the top of the hour. So this was customized configuration. Another something else you can do is you can also connect to Helm charts. And I have pre-configured this. So this is not configured by Terraform. This is, well, pre-configured just to show you how this works. So I'm going to my AKS cluster. This one is running on Azure. And what I've done here is I have installed a Helm release. And this is the shop Helm release. This is the same shop you just saw, only then on using Helm. So different technology. Let me check. I'm now looking at on the cluster level, but I have to go to the cluster group level. Add-on. Installed Helm release, and here we have our Helm chart that's up and running. And the nice thing here is that this one is pointing to a Helm chart on a Git repository. So I'm going to the same microservices demo. There's also a Helm chart folder that holds the chart.yaml file. So I'm pointing at this folder, and then I can use this Helm chart. For those of you who know the values.yaml file, I can update configuration options using this option here. I can add, get parts of my values.yaml file, change the configuration and add it here, save it, and then it will be applied to my Helm deployment. So in this case, this symbol shop is running here. This is another IP address. This is running on Azure. I can also change the branding here. It works a bit different, but it's the same as I showed you with Customize. I can change the branding here, save it, and this will take about a minute, and then the Helm chart will automatically be updated. So let's check if this branding has changed. Yeah, we have a new branding here, as you can see. So this is changed by Customize, by updating the Git repository, and the same will happen here if you have wait a few more minutes. So I hope this makes sense. Gives you an idea of the power of Tanzu Mission Control. And with that, I give the mic back to you, Robert.
Okay, will you start the PowerPoint again?
Of course, yeah.
Just take the 2 last slides. So Victor, we had a question before when you did the Terraform. So somebody asked if you could share the Git repo that you used. So, and I know you are a heavy blogger. So, so maybe that's something for the blog article.
I will certainly make a blog article about this specific demo. The files, I'm not sure if I uploaded them already to my Victorious repo. Let me see. It should be here. Tanzu Demo Essentials, TMC, Terraform. There we are. These are the files.
We'll throw a link into the PowerPoint that we'll share on the webinars.tanzu.dk. So there's a link for it. So and we'll do that just after. Okay. After this is done. So perfect.
Very good.
Yes.
Do you want to stop sharing, Robert?
No, just jump to the next slide. There's only 2 slides left. Yeah. So wrapping up here. Next time we will, and thank you, Victor, by the way. Just
you're welcome.
Next time.
Thanks for the
next time I'll also get help from another of our colleagues, Matthias, and he'll be talking about data services. So, and data services, that consists of all the things that requires some kind of stateful data. That could be message queuing, could be databases, etc., and how you can actually run that on Kubernetes. And we have a few solutions for that. And if you jump to the next one, Victor. And then again, we have a couple of links here. So one for Victor's blog and and some other ones. And if you're interested in joining one more of these, then the next one will be on next Tuesday. Then we'll have a week's break, and then we have the last 2 coming up. So with that, I think we'll stay on for the next 5 minutes or something. Just if there's any questions, there's already been a few in the Q&A. But on that, then just thank you very much for attending this. And as soon as the recording is done, being processed by Zoom, we'll upload it to the webinar site, just like the 2 others. So thank you very much. Thank you, Victor, and thank you to all of you for attending this one. So.
Yeah, thank you all for joining and spending some time with us. I hope it was useful and valuable for you.
I will stop the recording then.